Welcome, everybody, to Dallas Personal Robotics Group Robot Builders Night Virtual for July 14th, 2026. Tonight, we will do our normal robot presentations and then open the floor up to questions that you may have. Kick things off, Robo Columbus. We've only got about 4 months until Robo Columbus is here. Get your robots ready, get programming, and get testing. It's coming quick. Even quicker, Moon Day 2026 will take place Saturday, July 18th at the Frontiers of Flight Museum. DPRG is looking for volunteers. If you're interested in showing off robots or helping out, contact Paul. He, I believe, is coordinating everybody to get ready.
I think the number has been set, Paul.
All the news I have. Aside from that, if we're ready, we'll go with our presenters. And yeah, I believe you're first.
Yep, I am. Okay, so what I have here, let me just pull this up. So I have this the RC car with me. I don't know if you guys can see it.
I don't know if you're speaking. We're not hearing you at all. That's a nice platform.
Can you hear me?
I can hear him.
Can y'all hear me?
Some of this can,
yes.
I think.
Yeah,
We are not hearing
just a little quiet.
Yeah. But yeah, I have this car with me. I know a couple of y'all already.
You can see your microphone is talking, but we're not hearing any noise from you, any sound. At least I'm not.
Pat, I think
can
some
hear
of
him
us
fine,
can hear him. I don't think you can.
I guess that's my problem.
It's probably
Yeah,
Carry on.
I can
It's my
hear him.
video, my issue.
Okay.
yeah. Where was I? But it's got the ESC or the electronic speed controller, a battery, a motor, and of course my Arduino, which I'm trying to make my RC car autonomous. So it tries to like avoid obstacles while traveling at a certain speed. When it does come in front of an obstacle, it's supposed to like make a reverse and like, change, its pathway to avoid collision. But so far I've got I was able to control my speed, and I did test my sensors. Each of them were individually working themselves, but I'm just trying to make them communicate with the steering servo in the ESC, but I still haven't been able to do that, and I am having a little trouble here. So I'm looking for like, maybe a person that has like some knowledge that could help me connect, like make one system talk with another, if that makes sense.
So, Doug advised you on Saturday to look up the specs for the ESC and find out what kind of initialization sequence needed to be sent to it. Have you done that, and have you found the specs on it?
I have not done that, but I haven't done that. But I did like eventually test all the sensors without even having to like change up the wires or swap the sensors from different positions. I made up with a specific code that like tests it out to see, which fortunately it did, and I was able to figure out that they do work themselves. So
Yeah.
Okay, so the sensors are working, and you can control the speed. Are you using a servo driver for controlling the speed?
Yeah.
So you're using the servo library?
I'm trying to use the servo, but the code is not really working properly. That's what I'm trying to do now.
Okay.
The steering, you're saying the steering servo is not working?
I think there was a code that was meant to work the steering servo, but for some reason it doesn't.
So this is Ackermann steering, right? You got front wheel, just steering mechanism.
Yeah.
Yeah, it's basically a standard RC car platform. So it has a steering servo, and then it's got an ESC, and the ESC is an RC car ESC, which you can also control like a servo.
Oh,
Because it basically plugs into it generally plugs into an RC receiver,
right.
which sends the servo commands over to it. But he's got it plugged into the Arduino instead. And
But there's a way to, in absence of the RC receiver, there's a way to talk to it.
yeah, you can use the Arduino servo library to drive the servos and to drive the ESC. The one thing that may be going on is the Arduino only has certain pins that can do PWM. And so you need to make sure that your servo signal wire is plugged into a pin that can do PWM. And I forget which Arduino pins can do PWM, but it is a limited set of them on the Arduino. And so that might be what you're running into, is if you're trying to control it with the servo library, you need to make sure that the signal wire is going into a pin that is PWM capable. And I forget how they mark it on the Arduino. Unfortunately, I don't have one to tell you which pins are the PWM pins.
I got an addition thing that could happen too. A lot of those ESCs, especially those robotic those RC cards that you buy off the shelf, like I think that's what you have, right? They have a protocol which will forbid them from doing anything until they become neutral. Like if you wanted to go plus and minus, like backwards and forwards on it, on the speed, you have to come neutral, stop first, and then move back and forth. And if you don't start in a stop spot, they will refuse to do anything. That happens too. I don't know if you've accounted for that yet.
Well, there's also a required dwell time, especially when you're using like a PWM. You don't fire it every cycle because you need like a 40 to whatever it is, 60 millisecond gap in between your pulse widths to control a servo or ESD. And I've found if you repeat it too quickly, some servos will work, some won't. The newer ones, the digital ones, require a lot wider gap. So that's another issue. But really, to see what's going on, you need an oscilloscope to watch the pin, the signal pin, to know what it's supposed to be doing. Because other than that, you're really just kind of guessing.
Yeah, I was just going to suggest the exact same thing. You got to have either a scope or a logic analyzer or both.
Are there a couple different types of steering servos? I thought some of them were just like bang, bang. You turn it on for a certain width and, it slams over and then you let it go and it comes back. And
well, it has to do with the width of the pulse, right? So 1.5 millisecond is neutral. And Paul's absolutely right. Some of the ESDs have to be in neutral first before they'll really kind of initialize or start up.
Yeah.
But then, then that pulse is just modified either between 1 millisecond and 2 milliseconds for, full left and full right or whatever, forward, reverse, depends on what you're driving with it.
And
do you have any identifying model information on the ESC that would help you look up its data specifications and its interface?
I do see some of the details. I'm not sure what it says. It looks a little small, but I'll probably look into that later after this meeting.
Yeah.
Well, a lot of them too have like an initialization button. So where the scenario is that you hook the radio up to them and then you tell it, okay, this is neutral. right? The radio signal, what I'm putting into you now, this is neutral. So there may be, and that should be in the specs, like we're saying, you know, to take a look at how that's set. But you know, not some of the ESDs don't require that. They just go again 1.5 millisecond pulse is neutral. But like I said, without a scope, you're really just guessing.
And do you have access to a scope? Would you be able to test it on a scope?
An oscilloscope?
An oscilloscope?
I'm not
If
sure.
not,
What,
there
I'm
are
not
some
sure.
very simple methods that you can look up online that allow you to get some basic low-speed information about the pulses using essentially the microphone input on a computer. Not good for really high speed, but for purposes of pulses that are used to drive a servo, probably quite adequate.
I'm not really sure what a scope is, but I mean, I am new here, but
Gotcha, I understand.
Well, then I would suggest that would be the next tool you put in your tool bag, is to know what a scope is, how to use it, and get a very inexpensive one. You can get PC interface ones, you know, off of Amazon, I don't know, $20. And, you know, they're fairly adequate for something like this. But if you're going to mess with electronics, and especially programming and sensors, it's an invaluable tool to have in your toolbox and to understand how it works and how to use it.
Are you a member of the Makerspace by chance?
no, I am not.
Okay. Because that would be the other thing, is to would be to find someone at the who can maybe meet you and help you at the Makerspace, because the Makerspace has all of those tools available in the electronics lab.
Mm-hmm.
And that's something that maybe I could help you with when I get back, but I'm going to be out of town for the next 2 weeks.
That sounds good.
You can get one of these for very cheap on Amazon. And
Yeah, and it's
USB, and it hooks up to your computer, and you can analyze the signals up to 5 volts. And it comes with a free program to use it. Very, very handy for troubleshooting that sort of thing.
So you can,
How many channels is that one?
I think it's 8 channels.
Oh, it is.
Yeah, I think-
okay.
I think
So
that
more of a
one
logic
does
analyzer. than-
protocol.
Yeah, this one
Different
here will do
protocols too, doesn't
protocol
it?
as well. You can analyze different serial protocols. I think it'll do I2C, a bunch of different things.
Yeah. Pat, you're showing your logic analyzer, right?
It's a logic analyzer, not a scope.
No, it's good. Yeah.
Yeah.
but some of them
Way
come
cheaper,
combined,
way cheaper than a scope.
and you can get scopes in the same form factor. So think of it like a voltmeter that can chart the voltage over time. So basically,
Yes.
if you have a voltmeter that can measure the voltage signal like every millisecond or really quickly, so the voltmeter just takes those, captures the voltages on a line, and then it can plot them for you, and it lets you see, like Pat has an 8-channel one. So imagine 8 voltmeters. You just put one up to your trigger pin and one up to the PWM, and you trigger it on one, and you can see when does this pulse happen with respect to that one.
You can look at timing relationships.
Yeah.
Yep.
You can check to see that your software is when you write to the registers that it's making the voltages change in the way that you want them to.
Pat,
And-
you were showing us Saley Logic Analyzer clone there, I think, right?
I think it's a
Do
clone.
you have a link to it? Maybe you can put it in the chat for reference.
Oh, I can find one. I
He's,
can find one. They're fairly
Chris,
easy to get.
mine is always sitting on my desk. I have the same thing Pat's mentioning. They're about $8 or $10 Canadian.
Yeah, they're not very much. I'm gonna
Do
try
they
to
still
find.
make the models you guys have, or have they gone beyond that? Or
Well, these ones have been available forever. There are nicer ones that you'll pay a little more money for. But to be honest, start with something really simple. It's easy to understand and hook up. The software is available in multiple formats. And if you break it, who cares?
It was cheap.
Yeah.
Now those things, they're worth their the money in gold. I mean, they're worth their weight in gold, right? I mean, it's $10, but you know.
And then when you want to see the analog version, then you can have a look at entry-level, more traditional oscilloscopes that range all the way from a passive network that feeds a signal into your microphone input on your regular computer, all the way up to, well, however much money you want to spend. A 40 megahertz digital storage scope, which plugs into my Windows computer or a Linux computer, which cost me about $80 Canadian. And I think, Pat, you have one as well.
Scope?
Yeah.
Yes.
You have the, what's the brand name here? A Handtech.
Yeah.
The level Handtech scope, Hantek.
It's
Again,
in my
a little bit more
LC.
money, but well worth it.
Yeah.
Well,
I
you
got my-
notice,
Gave up every other scope I owned because I didn't
you
need
notice
it.
my scope is very conveniently accessible to my workbench. So, I mean, it's one of the most used tools I have.
Yep.
Sometimes you just have to throw some money at the problem, right? Instead of banging
Yeah,
it against the
well,
wall.
it's,
Well, start cheap. You're new to this, so you don't want to spend a lot of money yet, and you probably don't have to if all you're looking at understanding better is the signals that are going to the servos, because they're quite low speed.
yeah, that's true.
And they're only digital signal logic levels. You don't really need to see analog yet. That's something you can move up to.
Take a look at the link and see if that'll work for you. I don't know if I got the short link working. That's just one I pulled up.
Anyway, and also follow up on whatever information you can find on the make and model information for your electronic speed controller, because once you understand the protocol that it needs, it'll be easier to understand if your software is giving it the correct information. Do it for both the steering servo and the electronic speed control.
I would also suggest it's probably easier to troubleshoot and get the steering servo working because it doesn't require an initialization protocol. So you just send it a signal and it'll move left or right. Once you have that working on both channels for your speed control and your steering, then you can work on the protocol to initialize your throttle.
Okay, that sounds good.
Yeah, I was going to suggest the same thing, to start with the steering servo, because it'll be the easiest one to control. You could look at any of the Arduino examples for working with servos, and it should work for the steering servo.
Did you?
And then once you
try-
get that working, you can try the ESC directly. You could basically swap the steering servo for the ESC and see if it works. But try and get the steering servo working first, because that'll be that's going to be the easiest one to get working.
The other thing you may want to consider getting is a very simple servo tester. I'm going to show you one here. These are about $1 each on AliExpress. You hook it up to a 5-volt power supply. You plug your 3-lead plug from the steering servo into the end, and you can turn the knob and see the servo moving. Now you know your servo is working. These things are invaluable for testing servos that are of the simple type. They're harder to use on sophisticated electronic speed controllers. As has already been described, they tend to have different protocols. But very basic servos, that gadget takes all of the worry out of it. You don't have to worry about whether your program is right or whether you're using the right pins on the computer. Just plug one of these in. They're about $1. It's called a servo tester.
Okay.
Some of those even have a readout, right, for how many milliseconds? Because the pulse width from like 0 used to be 1.5 milliseconds, plus or minus 500, and some of them just have a digital readout as you turn the knob, so you don't even need a scope because it tells you what it's going to spit out.
And I admit I'm I'm spoiled because as soon as I hook up one of these, my scope's already hooked up. So I just didn't want to use something else to try and stimulate a servo that wasn't working until I know the servo itself is working.
Right.
Divide and conquer. Same thing with your electronic speed control, depending what its protocol is. See if you can get it to work separately from any other control software. Just make the wheels go round and start there. Can I ask you one more thing? Could you hold your model up again to the camera? I didn't notice it before.
Yeah.
Oh, it's quite large, isn't it? That's good.
Yeah, this is like a hobby kind of RC
Oh
car.
yeah, about a 1/8 scale or 1/10 scale.
Mm-hmm.
Probably.
Yeah, then he has sonar sensors on the front, back, and the sides.
Oh yes, I see them. That's nice. That's a really good start, I think.
Yeah.
Yeah, it looks like the pins on the Uno that do PWM are 3, 5, 6, 9, 10, and 11.
And,
They have a little
Okay.
using it,
From 2 to 13.
Yeah, they got a little squiggle beside the pin number.
Yeah.
If it's a pulse width pin.
See it or not?
Yeah, yeah. Same exact thing.
Yeah. So 1, 2, 3. Looks like 6 pins total.
Yeah, that's what I seem to remember. I know it's limited on the Uno, and the Mega has quite a few more, but it's still only certain pins.
Yeah, I think the Mega has like 13 pins or something.
So I noticed you have a lot of ultrasonic sensors around the perimeter of your car. There must be perhaps 8 of them or something like that.
There's like 5 of them. There's like 3 at the front and then 1 on the side.
Have you been able to get them to work and get distance measurements from them?
Yeah, I did. I had this one code that I was temporarily using to see if it would print like the distance and like to see if it would send the sensors out.
Okay. I take it they are the very basic ultrasonic transducer, so you have to send it a pulse and then watch for the returning pulse.
Mm-hmm.
Okay, so you've been able to get that to work. That's a very good step going forward, because to be honest, those are not that easy to get working correctly, especially 5 of them. So that's a good sign too.
Yeah.
So yeah, like I said, if maybe if you could work on that, and then maybe if you if you'd like to get together with when I get back, I can get together with you if you want.
Mm-hmm.
If you're still stuck, and we can try and debug it, I can meet you at the makerspace or something like that.
Yeah.
I don't know if anyone else would be able to meet you sooner, but
I can't meet you, but I've shared a link to the servo tester that has worked well for me, and it reads out in milliseconds or thereabouts. So you can very easily tell what kind of signal that you're feeding into your servo without an oscilloscope. $12.
Yeah, I thought, wasn't the period for servo pulses like 50 milliseconds, and it ranged from 1 to 2 milliseconds?
It's around 50 hertz.
Yeah.
And, I think it's pretty tall.
Yeah.
It's pretty tolerant, so it can be plus or minus a lot of hertz on the period. It's the pulse width that matters.
Right.
As I remember from the one I assembled in 1970, early something. I mean, they were all the first ones were that I remember building were based on the 555 timer, right? So basically, the pulse would come in, and when the pulse came in, the 555 would start to charge the cap, and when it hit whatever voltage threshold that, and when it started to charge up, it would set the pulse high, and then whenever the voltage on the cap reached a certain level, it would shut off and bring it back down again until the next trigger. So it was how long, literally how long it took to charge the cap. That's how wide the pulse width was. And it was from 1 to 1. And it had to be tolerant because the parts were so bad in those days, right? 10% resistors, Lord knows what capacitors, maybe they don't charge. And it worked, right? It worked robustly, remarkably so.
555 timer was an excellent circuit. It worked for everything.
I think you'll still find it around. I mean, that concept it's just so simple.
I think I still have my first servo tester that's based on a 555 sitting on the shelf here somewhere.
I mean,
it's in a big box.
the chip was perfect for the tester, and it was the same part in the servo. And if I remember right, like when they talk about some of these super duper high speed oscilloscopes that can measure like gigahertz pulses and such, on the front end to capture certain kinds of pulses, they might use something, or just certain kinds of things. They might use a 555 style circuit to capture. Like they use peak detectors, and they'll use those just to capture super fast signals somehow. Okay, I'm going to stop rambling because I'm way out of the deep end now.
Well, hopefully we give you a couple of options to look at. Yeah.
Oh yeah.
And Mark has offered to help out if need be, if you can make your way to Dallas Makerspace.
Yeah.
So hopefully you can get some luck with that.
Yeah. So try looking into a couple of those. Double check that you're using the PWM pins, and try and get your steering servo to I think that's the first step.
Yep.
And then if you have any other questions, if you have my email, you can go ahead and email me as well.
Will do. Thank you all for all of your help and some suggestions I could do next with this whole shenanigans I've been trying to do with my RC car.
Okay, well, good luck.
You'll get there.
Yep. Thank you.
Oh, thank you. Up next, we have Tom.
Oh, okay.
Some blinking lights.
Oh yeah, just not much to show, but progress on my little project. I mentioned that in order to have a suitable remote control for the latest outdoor robot I'm building, I was going to, let me turn this around. I was going to modify my oldest, there we are. Let's get rid of this. I was going to modify my my oldest radio control system, which is about 1970s vintage. So I've removed the electronics that used to be in it, and I'll show you that just because it's cool. That's the electronic board that was in it. All transistors, 6 channels, worked really, really well on 27 megahertz, amplitude modulated. You wouldn't dare use that these days. So it's gone. I have added some toggle switches to the top of this. I've added a display to the front. Ooh. And I've added some push buttons to control the display. Inside, I've replaced the old C-size battery pack with a 2S lithium-ion pack I made up. That's the back of the LED, the back of the display. This circuit board, you can only see the back of it because all the parts are on the other side. But there's an ESP8266 and a switch mode voltage regulator for 5 volts. And tucked away under here is what I call the analog board, which basically has an 8-input analog multiplexer and a couple of simple 3-bit D to A converters. The 8266 only has a single analog input. So I'm using a multiplexer to get the joystick, the 2 joystick pot inputs, as well as I took these 3 switches and stuck them into one D to A and used the 3 push buttons, which are on the other side, go into another 3-bit D to A. So now the push buttons and the toggle switches are also analog inputs. Plus there's some voltage monitoring and a few other things. I will run this thing using the ESP Now Wi-Fi capability. I'll run it in both directions so I can do some telemetry as well. And at this point in time, I just have power on everything, and therefore you can see the blinking light, which is the test software that runs on all these things when you first take them out of the box. I have a bunch of software that I am browsing through to decide what I have to modify to make this thing perform the way I want it to. And that's progress so far on this conversion.
Then what are you going to use it? What are you going to use it for?
Oh, my robot's too big to pick up and show you. The robot's sitting on the next desk over. It's my large outdoor differential drive robot. 8-inch wheels. It's about 2 feet square. It's already functioning at the motor and encoder level. And it has an I2C interface to provide control and information. So it's kind of the first stage, the level 1 control system for the robot. And then I'll add some higher level capability and add some sensors into it and some autonomous operations, but one step at a time, one level of control at a time. I figured I should get moving on converting these radio control transmitters I've been planning to do for a while in order to have a little more sophisticated remote control and deadman switch capability for these things. Hence the side project.
What about the potentiometers? I mean, from that vintage, they're bound to be noisy. Have you checked them?
Oh, they're not noisy. These things are, they are extremely well built mechanically and electrically. Way better than you can get out of commodity grade stuff.
Is that why you decided to reuse this sort of enclosure? Yeah.
That's part of it. Yeah, these are really, really good. And the enclosure is big, so you can put lots of stuff in them.
That's cool.
You can see this is just half of it, but it's twice that thickness.
It looks heavy.
Yeah.
Pardon?
It looks
It's all
heavy.
that metal.
Oh, it's all plastic.
Oh, it is
Okay.
plastic. Oh, okay.
That's all
It's
plastic.
not brittle.
No, it's
Good
not
for
brittle
you.
at all. It's very easy to work on, actually.
Good for you.
Yeah, I'm not certain the age of this thing. I think it's a Futaba brand, 75 megahertz. I think really made for a plane, just because the certain.
I bought one of those about 1990. It's also no longer usable.
Yeah, there's this. Doesn't
I was
work.
using it as a training transmitter when I was in a model airplane club.
Oh, yeah. Yeah, this is my current version here. I've got a LoRa transceiver and a little LCD or OLED display, and I'm really just using the up and down portions of the two, because it's just a whole lot easier for me to do that versus one joystick where I have to kind of push left and right and up and down. This is just up and down, so it kind of limits it. And you talk about the like just powering it up, it's like one channel. It's supposed to be right in the middle, 114 and 114 and 116, but it's supposed to be 127. So I have a little switch to basically zero that out. So when I'm, and then it holds that value. I doubt you can see that, but it should say 127, 127 now. So, and that I found that, if it doesn't wake up as, 127, 127, your platform moves because, I don't have a deadband around the zero. So, and the LoRa works for really long distances. I'm trying to think. Probably I've tested this one out to 1,200 feet. And no issue. I don't know if the other ones go that far, but
Some of the projects I looked at to do conversions were using LoRa and were suggesting as much as 10 kilometers. So I don't know if that's valid or not, but it's a long, long way.
yeah. For low transmission rates and
But I figure unless my robot goes really, really fast, a couple of 100 meters ought to be plenty.
Yep. Yeah. So yeah, and all that stuff was on one part. It's a TTGo LoRa 32-OLED. So it had an OLED display. It had the LoRa transceiver, an ESP32, and that one actually had a little. I'm assuming they're all quarter wave wavelength antennas, but I think the ones that don't have that really don't go nearly as far. So anyway, yeah, it's kind of, it's always nice to. I'm kind of playing around with lawnmowers now, and if something happens, it's always good to control it or throw it into teleop mode and say, "Whoa, where are you going?"
I found that invaluable with my previous outdoor robot, which I had configured it to use one of these, and it was really valuable to be able to just take over and control it the way I needed to.
Yep.
So more than a dead man switch. But this one has no telemetry. It's very cheap, so I thought I would add some telemetry.
Yep. They still have their use. So.
Well, thanks, Tom.
My pleasure.
Interesting. Up next, we have Chris, if he's ready to go.
Yep. All right. Let me move a few things around. Okay, move this here, share that screen. So, hang on, allow. See if I'm going to do this right. All right, what can you see?
We're seeing your screen.
You are presenting, start sharing your entire screen. So you can see my screen, right? No, it's like it's confused sometimes how it shows on my
Yeah,
end.
we can see two
And you don't
traces from
see
the LiDAR.
any message on top of it, right? No message on top of it. Okay, good.
Yep.
All right. So talked about my LiDAR challenge before. So just a quick refresher, right? So I have the spinning LiDAR on top of my 8-inch circular robot, and I've probably shown this before. It's all good when it's stationary, right? But the moment you start moving, and I know other people have reported issues, right? But in my case, this movement here is purely turning in place, and it's a bit of a worst case scenario. So the moment you start moving, and with these cheap, slow LiDARs that spin at, around 10 hertz, you get distortion or warping of the LiDAR scan, right? So again, it's just a refresher. I know most of you have seen this before. So that's what you get. It confuses the downstream algorithms. You feed this into RAW's navigation stack, to just get all confused by this, right? It's just, and even, you're not constantly turning in place, right? And I'm kind of deliberately doing this here, so I can collect some data, but even if you just, you move and occasionally you make a turn, right? It's like it completely messes up the data. Navigation stack gets confused, right? And it's just making the whole navigation not working well. So now I talked about this before, right? I did come up with my own algorithm. It's not bad, right? So again, left this kind of stationary, and everything really should look like that, basically, right? I mean, if a given algorithm is able to fully undistort the distorted LiDAR scan, right, you would expect to see a LiDAR scan that looks exactly like the one on the left, no matter the rotation or the movement that's going on, right? Well, my own algorithm, it managed to remove sort of this distortion, right? So if we go back for a second here, right? So you got this whole weird thing going on here. Well, okay, so clearly it was doing a pretty decent job removing all that distortion, but there were two problems that still remained that, I put it on the shelf a couple of years ago and never really had a chance to come back to it until now. The two problems that still remained are somewhat obvious, right? One is the whole thing when I was turning counterclockwise in this case, the whole map shifted clockwise, right? You see how this hallway layout is kind of rotated clockwise. And I'm just showing a static image here to make this go smoother, right? But I'm actually rotating. I'm spinning right now in place counterclockwise. And while I'm spinning, my whole thing is shifting the other way, which again is a problem. It's confusing other algorithms. And I could never really get to the bottom of that, why that's happening. Again, at some point, I just had to put it on the shelf. The other problem you can see here, you see this gap in the wall? Well, it is actually deliberate because so my algorithm deliberately makes this gap because if I didn't make this gap, there would be these weird artifacts, floating around. Again, that's another thing I could never really get to the bottom of what's going on. It was pretty obvious that this weird ghost, whatever you want to call this artifact, is kind of following, right? This arrow is pointing is representing odometry, right? It's basically shows my current heading. Again, picture this thing spinning. I didn't want to do it spinning now. It just makes the demo harder. But picture this spinning and this artifact is kind of spinning along right with it. And so you have this thing following the arrow basically. And it just looks like that when it's stationary. And so again, could never get to the bottom of it. Again, it's causing confusion to the other algorithms. So what my algorithm did is, and that's why these pixels are in red, I basically came up with the heuristic that says, well, the data that's right in front of me, at some angle, I can't trust it, right? There's some artifact there. I want to get rid of it. So I'm just deleting it, right? So on the left, I know it's not the exact angle right now, but that's why these scan data points are not there because my algorithm has deliberately deleted them because I know there's garbage there that I don't want. That's just going to confuse other algorithms. Okay. So that's how far I got, right? So this whole tilting thing while I'm rotating and then this artifact that's following along, couldn't get to the bottom of it. And so now recently started revisiting this, decided to throw some money at the problem, so to speak, not in the form of a more expensive LiDAR that spins, 5 times faster and then kind of makes the problem more or less go away. But I threw some money at the problem in the form of in the form of tokens. All right, so I threw some token budget at the problem, and part of it is I wanted to, so I wanted to use this as a benchmark of sorts. I wanted to see what the fuss is all about with Fable 5, right? That latest and greatest from Anthropic, the highest end sort of coding model that's currently available. And I just wanted to see, okay, what can these things do for me when it comes to not just writing code, because I've done plenty of that. It works. I know they can write code, but this is more of a problem-solving exercise, right? So let me first show you what it ended up producing, and then I'll just a little bit more about how it did that. So what it ended up producing, so again, the reference point, again, mine did a good job at removing the warping effects. I had this whole tilting going on, and I had a large gap here in the data, right? That wasn't ideal. So the AI, okay, so this one is, like, I tried Fable 5, I tried OpenAI 5.6 Sol, and they all in the end, did more or less equally well. And we can talk about how much it costs and all that. But this is what the AI produced. Okay, again, this is just a snapshot in time, so you don't see really the full image. But this is rotating right now, and you can see how the two problems that my algorithm still had in it are solved. Right, this thing is now not tilted. Right, again, if you look at what the starting point is, right, this left side here, this is our stationary initial scan, right? Again, all the scans should look like that if the algorithm is perfect. And so the AI there's no tilting going on. I'm spinning right now in place, but my scan data, apart from some jitter, and again, you can't see this right now. Well, actually, you can if I hit on pause here. There's some jitter because the odometry is not perfect. But the important thing is the whole thing is not rotating, right, in the opposite direction of robot rotation. So it figured out what's causing that. It solved it, fixed. The other thing you can see here, okay. You see how it's also deleting some points here? It figured out what's going on here too. Now, it can't make up data when there is no good data, right? So it didn't do that, but it did better than my simple heuristic, right? I just said, this angle right in front of me, delete the data points. I knew that was primitive. I knew there was a relationship between how close the target is to the laser, which way I'm turning, how fast I'm turning, right? All of these determine how much bad data I get that's right in front of me. And it has to do with the LiDAR is rotating, you are rotating. At some point you overlap, you kind of tripping on your own data as the robot's rotating, right? It figured all that out, right? And basically said, well, it's the best we can do. I'm just gonna have to blend this out. But you can clearly see the amount of data it's removing is very much a function of where we are at. It's not just removing a fixed amount of data, right? The closer we are to the wall, the size of that artifact that kind of is a problem, it becomes almost non-existent, right? And you can see that here. If I made the arrow shorter, you could see there's really just a tiny gap in the wall here, right? Because that's all that needs to be removed. There was just a tiny artifact, almost not worth removing it. But the steeper that angle between wall and LiDAR, right, the more of an artifact. And if I didn't delete the artifact, right, it would be kind of charting out to the back of the wall here, right? The bigger that artifact is, you can see it here again, steep angle to the wall. Well, it knows it needs to delete a certain number of data points because they're just not trustworthy in this situation. Okay. So it did pretty well. I did use Fable 5 first. I wasn't really able to gauge, is this going to be a hard problem for the AI? I mean, in hindsight, it wasn't very hard for the AI. Okay. It was hard for me. It involved math. My head was smoke. There was smoke coming out of my head a couple of years ago when I came up with this algorithm, and I was real proud of myself. I did real math. So it just didn't break a sweat. Okay, it just did not. Well, it did have to work on it for an hour. Okay, so that's maybe an exaggeration. It did have to break a sweat. It did have to work on it for an hour. It did have to burn a couple dollars worth of token budget. So it didn't come for free. But both Fable 5 and GPT 5.6 Sol, they just found the problem.
But you were using thousands of people that have tried to solve this before you and their experience, and it was able to collate that where we cannot. We just can't keep it all in our brain, right?
Exactly. Exactly.
Oh, there goes the magic. Oh man.
I'm sorry.
Yeah, I know. I mean,
Sorry.
I'm happy that.
Hey, do you
because
want
if
to
I
know how
find it-
how David Blaine slept in ice for 2 weeks or whatever? Never mind.
I'm both happy and sad, right? Because again, if I find more time again to fiddle with my robot, I can use this now. Done, right? Move on to the next problem. On the other hand, like I said, I was really proud of myself when I came up with the algorithm, right? It took a lot. It took hard work. Again, for other people, it might have been easier. For me, it was a hard problem, and I enjoyed solving that problem. And you throw some tokens at it, problem is solved.
I think you're hitting on a point here. This underlying point is you use the AI to do the stuff you don't care about. Well, not that you don't care about, that you need to get done, and let yourself work on the interesting problems or the problems you find interesting, because that's what you should do. You should work on the interesting stuff and all the stuff that's mundane, like we're having this discussion today at work. If you look at the code that I would have written 5 years ago versus the code that's getting written out for the AI now, the code may have been 6 or 8 lines long. The code that gets written by the AI now is about this long, and just in general sense. But what's happened, if you look at the code, my code that I would have written in 5 or 6 lines is actually in there. The rest of this code is making sure that this line here does not break in any substantial fashion. I just don't want to write that other stuff because it's, I mean, some of the most boring code in the whole planet is to do nothing but validation and guard code is what we call it. It just sucks. It needs to be done. Nobody wants to do it. And luckily for some people, and me, and your program never hit that. But the AI doesn't know that, and will go ahead and do that for you, so you get a better quality of things coming out of it. At least that's the discussion we were having today. Yeah, work on what you find interesting. Let the AI do the rest of it.
And let me just to be clear, though, I mean, I didn't make it deliberately hard for the AI either, right? So I didn't throw just the raw bag file over the wall and say, oh, this isn't, give me something that's cleaned up, right? So I did put some time, and so I put my manager hat on, right? So I got another engineer that's going to do the work for me, but I got to explain what needs doing, right? So I did spend, probably 45 minutes or so laying out the problem, defining the problem, right? What is going on here? So I did give it some good input, right? I did give it screenshots. Hey, this is stationary data. I expect everything to look like this, right? This is the example of what the bad data is. So I didn't just put a single prompt in there. That's just garbage in, garbage out. It'd just be waste of my token budget, right? So I laid out the problem, just like you'd be doing it if this was another human doing it, right? You'd have to explain to this other engineer what actually is the problem, and give enough of the starting point for someone else to solve the problem, right? You don't hide information that you already know. Now, I didn't give it the solution, but I just defined the problem.
Chris, did you write that goal.md, or did you use a GPT to help write it?
So both, right? So the process I've been using in a lot of people that a lot of YouTube videos and podcasts I'm paying attention to is I do the rough draft, just no consideration for formatting and structure of the document. I just get all my thoughts on paper. A lot of people have been recommending even using a voice and recording it. I've been playing with that as well. I just haven't found the right workflow there yet and the right tool. But yeah, I did a rough draft, right? Just blabber, blabber, blabber. And then I asked one of those models to basically clean this up, put some structure around it, right? And then turned it into this document. I had to do another round of it because I realized I left some things kind of a little bit underspecified. I wasn't clear enough as to what I want the output to look like, right? So that leaves too much up for interpretation, because I wanted to compare Fable and GPT, right? So, but then if I'm not clear about, okay, I'm gonna use this in the end in a real-time fashion on a real robot, I don't just want an algorithm. I need a real-time pipeline, right? Input data coming in, cleaned up data going out. So unless you lay all that out, you may or may not get that, right? So I refined the document a little bit, explained it a little better what I'm looking for, and in the second round, the other thing I did that no one really, in the end, managed to really do anything about is I did mention the thing about artifacts. I did suggest in here somewhere, hey, to measure the goodness of the algorithm, you may want. I told it the way I'm going to look at it when it's done. I'm going to use RViz. When you do this, and if there were any things going on, any artifacts and whatnot, it would immediately show up here, right? You know what I mean? This is now a really, and you see it here, right? So you have a little bit of a leftover of this artifact. You see these little ghost dots here, right? So I gave it those kinds of clues. I told it how I'm going to evaluate the algorithm when it's done. I did tell it to do this sort of thing of using a multi-second decay time to see if there are any artifacts, but they didn't catch that. So all this artifact removal business that I was just talking about that it did a good job at, I had to do that as a part 2, right? So it did the first round where it basically did just the dewarping perfectly. Those artifacts were still in there, right? Those artifacts, this guy right here on the right, this little artifact on the right side, that was still there in both Fable and GPT 5.6, even though I've given it a little bit of a hint that there might be artifacts in the end. So I had to, in both cases, tell it, well, now this looks good, but now there's one more thing that needs tweaking. So I gave it 2 additional screenshots, in fact, right? So I gave it this screenshot and another one to say, look, this is what's happening. Now make that go away, right? So that was then around, the second prompt. It was working on getting this basically eliminated. And again, so the work that I had to do was in explaining the problem, right? So again, I did put some effort into this document. I did even explicitly suggest, hey, you may want to do like a design of experiments type of thing. There's going to be all kinds of parameters, timing related, an offset here, an offset there, some noise here. You may want to do a little bit of a design of experiments to figure out what are the right knobs that need tweaking, right? And where do those knobs need to be set to? And because that's how I would do it, right? If it was clear to me that that's how the problem had to be solved. So I did give it that kind of hint. And so that's kind of the approach it used. And it, and I told it to leave a record of what it's doing. So you can see in some cases, it's produced. Okay. So it produced a lot of data that, almost like an engineer would produce with all kinds of intermediate step analysis. And here's what the finding was. And right. So it produced all kinds of stuff. Frankly, I haven't fully digested that. Right. I didn't have the time, but they all were producing all kinds of charts and plots and doing all kinds of data analysis. And in the end, I thought I had a decent screenshot here that kind of illustrates what I was trying to say. So, and the Debugging version 2. All right, so it followed a pretty good process, step by step, trying, evaluating how good the algorithm is, which I did ask it specifically, hey, one of the things I want as outcome in the end is I want the tool that you're going to have to create anyway to measure the goodness of the algorithm. I want that tool as one of the outputs, right? So I can use it later, right? So I did give it that as a requirement that, hey, by the way, I'm going to want that tool and you're going to want to use it too. Otherwise, how would you're going to have a way of measuring how well this works, right? How well is the algorithm doing? How well is it fitting that ideal line, right? That starting point, right? How well is the dewarped scan lining up with this, it's gonna have to have a way of measuring that, quantifying that. So they all did that, right? And left all kinds of stuff behind as they were going through their experiments, right? It wrote scripts, right? Stepping through a range of offsets, coming up with a hypothesis. Okay, let's just assume there's some offset that needs to be applied, and let's just do a loop going through a range of numbers, right? And then for each position of that knob that it was turning, right, it was measuring how well is the algorithm doing. Oh, okay, here's the sweet spot, right? Let's record that and let's go with that. Let's move on to other knobs that we need to identify and then tweak. So it was impressive. But on the other hand, I wanted something. I need to find something harder now, because I temporarily upgraded my Copilot subscription so I can play with Fable 5, which is supposedly super smart. And clearly this wasn't hard enough for it, so I need to find a harder problem. So if someone on the call has a harder problem to solve, I'm out of token budget now for this month. So this burned quite a bit of token budget. So in terms of how much this cost me, let me tell you how much this cost me. So the this second run here, Fable 5, right? So I have a $40 subscription now, up from $10, and with the $40 subscription of GitHub Copilot, I get essentially $70 worth of token budget at a la carte pricing, right? So it's not actually a very good deal, and that's why I won't have this permanently. But it gave me Fable 5. So the first pass through basically took about 765, let's just call it 800 AI credits, which at 55 cents per credit, you can do the math there. So it cost me it cost me almost $4, right? Basically to do that first pass through, right? And then the second path, like I said, it didn't resolve the artifact issue. So it actually that took quite a bit, but that could have been because I was waiting too long. I may have lost my, the cache. You benefit from some token caching, and I may have lost that because of the timing and how I was doing it. So this may not be a good data point, but that second pass through, from what I've seen on the previous run, it basically cost another about the same amount, or $5-6. So it doesn't come for free, but it did solve the problem. And
Can I ask a quick question?
Sure. Let me pause here. Yes, let me pause.
Okay. I was wondering if you've tested how robust its solution is. In other words, what happens when does it handle rotating the other way? Does it handle rotations at different speeds?
So yes and yes. Now, but that being said, right, so unfortunately, I collected this data, this RAWs bag file in 2020 when I was working on this. And unfortunately, for some reason, I only had this one data set, one bag file, right? So it's a couple minutes of data, and it's the robot spinning in clockwise, counterclockwise, alternating. So at full tilt, maximum speed, slower. So it contains a range of scenarios. Nonetheless, it's only one data set. So unfortunately, I didn't have a broader data set. I also don't have anything where it's just doing, X and Y movement. Okay, that's probably a whole other problem. That's not exactly the same algorithm, or it's an extension to this algorithm. But I was more concerned with the rotation. So I have a fairly big data. I would have liked more data sets, and because what I would have done is, okay, it's used this data set to tweak the knobs. Now let's see how well it does with this other data file, right? Would have been something interesting to do. So I don't know the answer. I don't know how robust it is, because it's obviously probably it didn't hard code anything about that specific data file into the algorithm. In hindsight, I should have explicitly made that a requirement to not do that, but I'm pretty sure it didn't do that.
Okay. I was just curious because sometimes when you do these things, it'll actually do a pattern matching, and what
Yeah.
the pattern that it matches isn't actually a solution to the problem. It's just solving the data set.
Yeah. No, it's definitely a possibility. My gut feeling is just because the range I have several minutes and all kinds of speeds and in constant alternating between the two directions. So I'm fairly confident that it would work
Okay.
on the actual robot.
Did you do this all from VS Code then?
So yes and no. So I did a couple of runs here. So I did Fable from VS Code because I don't have an Anthropic subscription, didn't want to get one. So that's one of the reasons why I had to bump up my Copilot subscription. So I did from VS Code, I did Fable twice, and I did GPT Soul twice, and then I used my regular OpenAI subscription with Codex to do one run through the same exact thing, but different harness, right? So because Codex is its own harness / agent thing, right?
Is the desktop one, the new one, or the?
No, because this was all on Linux, so I still used VS Code, but I used its Codex plugin, which
Right.
is
Okay.
Is this coming up? Yeah, it's coming up. So VS Code has a Codex plugin. It's just that even though we are in VS Code now still, behind the scenes, the way the Codex sort of prompts the model is different the way GitHub Copilot does it. And I could tell, right? I mean, in Codex, I was getting different output from the same model than I was getting it with GitHub Copilot. Right, because there's all these behind-the-scenes instructions that you don't even see, right? And there are ways to see it. It's kind of interesting when you turn some debug features on. I mean, VS Code GitHub Copilot is like sending 6,000 tokens worth of instructions every time you fire a prompt. And I don't know what those instructions look like for Codex, but they're not the same. And that'll right away off the bat, right, will steer things in one direction or the other potentially, and I could definitely see that with Codex.
Did you just let them rip, or did you?
I just let them rip. I just kicked it off, put it there on the side. I did have to watch my, I had to pay attention to, hey, am I going to run out of token budget? With Codex, I had to be careful, right? So with Codex, I can't actually tell you how much it cost me because the way their budgeting is more generous, but also less transparent, right? So I have the $20 OpenAI subscription, and that comes with Codex, and then you get this sort of 5-hour windows, right? You get X amount of Codex usage within a 5-hour window, and then it starts over with another 5-hour window, and you get a certain amount within a 7-day period. Now, again, they don't quantify it exactly the same way. In GitHub Copilot, right, it'll tell me exactly. So I'm at 90% for I'm at 90% for July. So I guess I'm done for this month with my GitHub Copilot. So this is, and every one of these credits, I had to pay $40 for these 7,000 credits, right? So every credit is 0.55 cents, right? So it's exactly how much this costs you. But with Codex, it's like I could see it depleting its 5-hour, budget window, and it was almost getting over. So I had to use one of my resets, right? So they give you a reset button you can press that they just hand out as a bonus sometimes to people, right? You say, I'll give you 5 resets this month or something, right? Just they want you to get hooked, right, on it. So you can press that reset, use that reset up, now now you're back at full, you know, your gas tank is full again now for your 5-hour window. So it would not have completed, I think, within my 5-hour token budget, because again, I have only the $20 OpenAI subscription, which you don't get much out of it. But what I've heard is that people who are really clever about this, technically, if you really time everything right, you can get a couple $100 worth of usage out of that $20 subscription.
I bet.
If you do it right? If you time it right.
Yeah, we've got at work. At work, we just got put on a budget, so the time of the never-ending breadsticks at the AI counter is done, right? So we got budgets and stuff, and we're looking at those things, and we've gotten fairly creative in watching what we're doing, and we're being very, very, very intentional. So we've got they give us windsurf licenses. Okay, so we're using windsurf now. Now it's called Devon, whatever. Okay, people like to change their name for whatever reason. They explained it, but I don't care. And so what it is it allows us to choose different things. So I can get GPT, I can get Opus, I can get Haiku, I can get a whole bunch of stuff. So what I've been finding though is for most of my daily work, because of what I'm doing, I'm not exploring new crazy things necessarily. I'm using stuff that's well known or easily found. I can fire up like spend a little money on like high-end Opus or GPT 5.5 or whatever the latest version of that spends a lot of money on it. And then once I have it generate a plan, I kick in something called SWE, SWE. SWE 1.7 dropped last Friday. I've been using it the last couple of days. It's really, really good. And it costs $0. It costs $0. So I don't know, I've not played in the Copilot, even on Microsoft MVP and all that kind of stuff. And I've got Copilot, and I'll find out sometime tomorrow whether or not I will be an MVP for another year. That's when they're all going to announce this tomorrow. But my Copilot, my GitHub Copilot is lapsed. Hopefully it gets renewed tomorrow. And so I might have to worry about that on the thing, and figure it out. But I bet if you don't allow it to change, if you pick the model you want, use the real smart model to generate a plan, and then once you have a plan in place, use the not so smart model to implement the plan.
Yeah.
We're getting very, very creative with stretching our budget and getting our job done within a budget of it. So this, you say you're getting a couple $100 worth of stuff where you play around with it. Yeah, this is game time, baby. You get to go. Let's go game it up. You need to know more than just throw a prompt at it, and also, like you were doing, coaching it, giving it a context, and where you giving it a box and guardrails and a strain of really what you care about solving. Will help with that budget a lot. At least that's work, anyways. Yeah, I think you're doing great, man. I think you're doing great, Chris. I think it's awesome.
Yeah, I mean, so the codec subscription, I guess, takeaway is the codec subscription is definitely a better value. It's just that it's user experience. So I'm not the command line, the terminal coding edge, and kind of that user experience is not for me. So I like VS Code. The codecs inside VS Code, just the way it presents the file differences to you, I don't find that user experience to be as good as what you get with the GitHub Copilot, where it kind of makes changes, and if you want to keep those changes, you're going to have to explicitly press the keep button, and the way it shows you what has changed. Maybe I'm just used to it. That might be part of it, but it is a bit cleaner and more intuitive than with codecs. But the reality is, if I were to do more stuff at home, I'd probably just lean more into codecs than VS Code. But I'm just so used to VS Code because that's what we are given at work. That's what we have at work. I have less sophistication at work, believe it or not, right? I got access to some other stuff at home that I have at work, but that's a common issue, I think, with this stuff. So it was interesting, but I need to find. All right, I'm out of token budget for this month, but with Copilot, and so I can't throw another problem at Fable 5. But what I really wanted to do is see what sorts of problem that matters to me Fable 5 can solve. Right, that's what I was really shooting for, and turns out this wasn't a very hard problem for Fable, right? So or GPT 5.6 for that matter. What I might try, okay, one thing I might try, and I may have to use my Codex subscription for that, is an experiment where I feed the same input into one of the lower tier models from OpenAI. Right? So I use the top tier, OpenAI. You pay for that. Once again, now if I drop it down 2 notches, right? Like GPT 5.6 Luna, for example, is the cheapest one. I mean, it is a lot cheaper. And
Can it do it? Huh?
can it do it? Right? I might run this sort of experiment if I feel like it. Right? So Luna takes 100 credits for every million tokens in, versus Sol costs 500. So Luna costs 1/5 of Sol. Okay, Sol is what I was using. Now, can this model that costs 1/5, well, not 1/5 per task, but 1/5 per token, right? Can it solve this task? And what I've been hearing, right? Sometimes the answer is yes, it can solve a certain task, but because it's a dumber model, it actually has to work, 5 times as long at the problem, right? So you end up back in square one. Yeah, you paid less per token, but you used a lot more tokens, right? So you used a cheaper engineer, but the cheap engineer worked for 3 weeks on the problem instead of your top tier engineer who did it in 3 days, right? So
Yeah.
Very cool, Chris. Really like what you got out of that in terms of algorithms. And I don't want to interrupt the flow.
I'm done. So just to be clear, that's all I had, unless there are questions. Right? Questions, go ahead. But there's nothing more that I had to present.
Okay, because I'm running out of light here, and I've got something I've got a demo to do.
Okay.
So
Okay, Chris, I just wanted to let you know, gave you a black star for all of your effort.
Nice, thank you.
Significant progress on that, I believe. It looks good.
And thanks for the review. That was really informative, very helpful.
Yeah.
Hey, are you ready, Paul?
Yeah.
Oh, okay. I was going to
Is
ask.
that okay? Right.
Next,
Go ahead.
Paul.
Yeah, I'm running out of light, so I'd like to do this if you don't mind. I'm not sure if I'm jumping the queue here.
No, you were next.
Show
Okay.
us your stuff.
Okay, cool. So I've got my my mower outside, and it's got RTK GPS, and it's there's a base station sitting on my gutter, and I'm going to, let's see, I'm sharing the raw screen, and I'm going to pin my phone, and I'll look out the window with it. And so now this works maybe 1 time out of 3, so I might have to give it a few goes. So I'm going to run the scripted mover to tell it to move in GPS space, so move map 1 meter. And let's go back to the server and see if the server will kick off. Yep, looks like it should be going. And is it going? Yeah. Can you see the mower moving?
Mm-hmm. Yeah, it moved.
Okay. So that was it. That was autonomous operation, navigating 1 meter using RTK GPS.
In low light.
There are lots of caveats, lots of things don't work, but they they're the sort of things that should be easy to fix because they used to work, like point-to-point navigation, and moving more than 1 meter and doing it more than once without restarting the action servers, just stuff that is broken, just needs to be fixed. But anyway, that was all I had.
That was autonomously moving 1 meter.
Yep.
Gold star.
Gold star there, yeah.
Congratulations.
Thank you. I was very happy when I got that going. It's been a while coming.
It's a good night. 2 stars.
Hey, Paul?
Yeah.
Can you give a quick update on where you guys got with Robbie for Moon Day?
Yes. So last Wednesday, when you were with us, we had Roby tracking. So I introduced face tracking using something called Media Pipe, which is a CNN solution set from Google that contains face recognition, and it was actually somewhat tracking the head, moving the head to keep the face framed up in the center. And if you stop, then after a while the face sitting centered in the view of the image, then it starts the arm moving and it does a little wave thing. On Saturday, we cleaned up some other outstanding problems, got the wrists working and make sure both arms fit in, and we had all the parts, all the side pieces, because we're going to take Roby to Moon Day, and he'll be standing his full 7 feet tall. And then the last thing that happened was that we observed that the webcam that was in Roby's head looked kind of straight ahead, so it was kind of high, and Roby can't bow his head down very far. So the image tended not to be able to get centered unless someone was standing some distance away, because he couldn't lower his head enough. And therefore, if he couldn't center the head, then he wouldn't do his arm wave, and etc. So Mark thought it'd be a good idea that webcam that I was testing on had a wider field of view. So he took out the old webcam out of Roby's head and glued that one in. But I don't know why that one shows the screen is real green. The image is very green tinged. Everything is either green or red, and there's no like face natural white sort of coloring, no browns, and it seems like that's so while it did produce a wider field of view, and he kind of like tilted it down, so Roby was actually looking down a bit more with the goal of being able to center somebody's face who's standing closer to him. It really didn't accomplish the goal, because then that sort of broke the face recognition. I assume because the color was off. I don't really know that. That's just an assumption. And so when we get together tomorrow night, I think that'll be the first thing to figure out is what actually broke, and can we fix it? So it's down to the wire.
Gonna say you could move the camera to his chin.
Thanks for the update.
Yeah, but
Thanks, Paul.
we've got it's kind of a big deal. What's happening at the Frontiers of Flight Moon Day exhibit on Saturday. We actually have two top-ranked teams. Kareem's team, Iron Rain, from the first Tech Challenge competition or organization, and then Trisha's team, which is world class level competitor from Vex Robotics, and so they're both going to be sharing the DPRG booth. So I'm not sure how we'll all fit in there. We've got probably 4 to 6 tables worth of space available to us, and 17 people on the exhibitor list at the moment. So it could be kind of dense in there. Might need to send some people around to like look at the exhibits and make some room. So, but I don't really have a sense of what the physical space is going to be like.
Hopefully the Moon Day people will be accommodating and give you a little extra space.
Well, I will tell you this, I will be there in person to help out or whatever, but I'm actually not going to bring anything, so you don't have to worry about me and my toy box. I will certainly man the stuff and answer questions, and I don't know, try to be funny, I guess, maybe. I mean, funny looking for sure, but funny, maybe. I don't know.
Awesome. Thank you, Harold. And Scott's going to be there, and maybe Mike and Trish and Doug and myself, and then the 2 high school teams. So we'll see. It'll be interesting. I'll report back on how it was and show some pictures next week.
That would be great
Cool.
for us to attend. Okay. Does anyone else have something they'd like to present? Ray, did you have something?
Oh, no, but I had a question for Chris. Do you ever, or anybody else that's really heavy into using AI tools, it's kind of like, I don't know, maybe that's my assumption, it's like a lot of times, I'll think, somebody else is, this problem that I'm trying to solve, I'm not the first one to try to solve it. So, is there research or techniques or, I don't know, maybe, can the AIs, or do you find they can learn from what are the questions that have been posed to them? It's like, okay, I'm sure the LiDAR, dewarping LiDAR, it's got to be a common problem. The first person that sets the LiDAR on and spins at any rate, they're going to say, oh boy, this thing's all screwed up. So do you find that you're asking initially, maybe, has there been any research done in this? Do the AIs have experience trying to solve this issue?
Yeah, so what I do in this case, so you're right, it's and at some point I did exactly that, and it's been a while ago. But so there's 2 ways I use AI in 2 completely but sometimes related ways, right? One is what I just showed, right? I mean, I need some code written, I need some algorithm developed, right? So that's one use case that's like in VS Code, in the IDE, right? The focus is I need some software, right? Now, what you're describing is kind of the research use case, right? And I do use it. I do use it for research too. But now it's a completely different tool. So now you're not in VS Code. Now you're in my case in ChatGPT, in the regular chat interface, right? And if it's if I wanted to dig really deep into a topic, and I don't know what they're calling it these days, and if it's still called the same thing, but it used to be called deep research, right? You turn that on, right? Then, and it digs really deep. Again, it keeps changing, and I haven't had a deep research kind of case. Google might have another name for it, although multiple platforms have called it deep research, I've seen. But you turn that on, right? You give it the thing that you wanted to research. Again, you gotta explain what it is you wanted to research. And at least last time I've done it, it comes back with a couple questions first. Hey, can you explain a little more, right? What it is you're looking for, this or that, right? And then it goes off and does its research, and it might noodle on that for hours, right?
Wow.
Yeah. So it really, so I mean, again, nowadays things have maybe converged a little more, right? Because even every prompt you fire off in ChatGPT, you don't have to tell it to search the web. I mean, 99 out of 100 times, it's going to do that anyway, right? You're not getting nowadays at least, right? You're not getting a reflex response anymore, when you use the thinking model. But if I wanted to research some technology, right, and I really need have exactly that kind of question, which I'm sure if I go through my history in ChatGPT, I'll probably find something exactly about the dewarping problem, having posed that question, and he probably came back with some stuff, and I must have decided it wasn't what I needed. Right, but that's what you want to do. But again, I don't know. I've said that before. I don't know what you get for the free subscriptions. You may not get that in the past, at least. I know you wouldn't get that sort of feature.
Yeah.
So with any of these guys, whether it's Google or ChatGPT or what's the other one here, Perplexity AI, I hear is very famous for its research mode, right? So you gotta pay some money, and then you get this kind of thing, and it'll really dig deep. It'll do a report. It'll tell you all the sources it has considered, right? It'll do references to all of that. So it'll dig really deep and do, in this deep research mode, it'll basically do a much broader web search, right? Than if it's just an everyday prompt, where it still will do a web search, and it will it'll kind of summarize what it found. But with the deep research, it does a much, much broader web search and really then give you a report in the end.
Chris, I'd add on to that, because I find it very helpful to for the things I really care about, that I want reputable sources. I'll just say cite reputable, credible sources by name and URL, and you can see that it'll separate the generic Reddit posts from the science papers and the academia stuff. And then another trick I've seen, slightly different contexts, but I used one of these with our CRM to analyze customer questions and pre-sales calls, for example. But if you ask it the right kind of question with the right kind of data, it'll figure out that it needs custom code, and not just little one-off Python to parse an image. It'll go right. Whatever it uses, it'll invoke codecs and import different data sets and run math on it and export CSVs for you without you having to specify that's what you need. You just say, look at this data. I want these kinds of answers from this data. Go analyze it, produce me a report. It's pretty remarkable in that way, in the way they're converging.
Yeah. But yeah, the deep research is powerful. That mode, and I want to check what it's called nowadays. It's especially. I mean, I know at some point I was something about Bluetooth. It was kind of, I wanted this, had some idea, right? So I really posed to sort of some question. Okay, how would I do this with Bluetooth? And there are some things where you don't want sort of a casual answer right away. You want it to dig deep, right, and really find everything there's to be found, and then give you the summary. And so there's ways to to tell it that's what you want, where you're not in a hurry for an answer. And you get this basically 3 tiers nowadays. I think you get in many of these platforms: instant versus thinking versus deep research, right? Determines how much time it spends and whether it's just a reflex action, right? That's coming predominantly from its pre-training, right? But then I never use I should say I rarely use the instant, right? I wanted to spend just a little bit of time, doing a couple web searches. Don't just give me a canned answer that happened to be in your pre-training data that's no longer, that's already out of date. So I rarely use the instant sort of mode of responding. Because I value accuracy, right? Whether that's at home or at work. If it's something at home, again, it takes, put the phone to the side and then pick it back up. Okay, that's now I have the answer. I don't always need the answer instantaneously.
It's your 5-to-1 thing, right? It's instant's fine if you need to know that crazy syntax for the Excel formula for parsing a date or something. Instant's fine. But other than that, if you have to take 5 rounds of the instant, when you could put a little more time into a good prompt and get the first try on a thinking, it's worth it.
Yeah, even if with the same prompt, right? Sometimes it's not a matter of, okay, you having to put in a good prompt. I just feel I can trust the output of the thinking model more, right? It has spent more effort on giving me an answer. It has looked at more sources. Again, even if it's not the deep research one, just the regular one, it has considered more sources, has spent more effort. So the probability of it hallucinating something is just less. Let's put it that. It's one way to put it.
Actually, I've understood it's a step beyond that too, because it's not just more sources, but it has additional loops to check its own work.
Right.
And those, I think that's the biggest thing for the thinking, is that how many extra times does it go around to make sure that did my answer actually answer the question that was posed?
Exactly. It's like the analogy I use is like it's kind of talking to itself, right? Let me think. It's been programmed to talk to itself because that fires off other neurons, right? That end up in the end making the right connections that give you then in the end the right answer. Now it's a double-edged sword, though, and a lot of people will tell you that with some of these models, if you dial up, because in GitHub Copilot, right, you pick a model, you can pick the reasoning level: low, medium, high, extra high, and you gotta watch out. If you dial it up too high, it might end up overanalyzing. It might kind of like get stuck in an analysis loop, right? Oh, I gotta consider this also. I gotta think about that, right? It's like a human has a tendency to overanalyze. That can happen, and people have pointed that out, that there's a sweet spot, right? And sometimes you need to go one notch higher on the reasoning level. But if you go unnecessarily high, it might just go on and on talking to itself, burning a lot of tokens in the process, because this reasoning, right, this thinking, this talking to itself, that's output. And you pay for it like you pay for output. And output costs 5 times as much as input, right? So if you look at any of these pricing tables, X number of dollars per million input tokens is always X times 5 as much for output tokens, right? So you gotta watch out with the settings, right, and how high you dial that.
Maybe it's like Tesla had the ludicrous mode, which was out of control, and so maybe the deeper thinking AIs have schizophrenic mode. They're just too smart for their own good, and it makes them crazy.
Oh, so one unrelated to this topic, but related to robots, I just forgot. I wanted to mention, I did have a chance for the first time to finally drive in the Robotaxi. I was in San Francisco a weekend ago, and well, they have Waymo. I mean, that place is crawling with Waymos. I mean, it's unbelievable. It's all Waymos in San Francisco, and so I on my last day there, I had to drop my daughter off, get her all checked in, and she refused to come with me in the Waymo, so I had to do it on the next day when she was at work and on the day I was going to fly out. So I took 2 Waymo rides and it went off pretty smooth. It was interesting. It was uneventful, right? In the end, actually kind of boring, right? In the end, kind of boring. Nonetheless, interesting. I paid close attention to right? It's showing you what it sees, right? It's got the screen. It's showing you all the perception that's going on, and it looked like it's doing a pretty good job at the perception, and it didn't, I didn't feel unsafe at any point in time, but it was interesting.
Didn't cross under any train gates that were coming down or anything, right? Was that the Waymo thing?
So I saw a headline and I hadn't watched the video on it, so I don't have any details other than the fact that apparently Waymo got upset with some of his passengers, which are a bunch of kids, called the cops, stopped and waited on the police officer to show up.
So what were the kids doing that warranted that? Were they destroying the interior of the car?
No idea. Like I say, I saw it. I put it on my list, and I got back around to it. I go, I gotta see this. So
little illicit drug use, maybe.
Hey, who knows?
So I ran across something interesting. Came across in the robot news feed that I thought you guys might appreciate, and I'll just share that. It's a video, and then there's some more live stuff. There we go. So this is from 1X.
Yes.
So do you trust your robot with your best crystal, you're saying? Is that the... Don't stick your finger in the socket.
What they're illustrating is the extraordinary level of I don't know why they smashed the bulb, but the extraordinary level of precision and dexterity that they've got in this hand that they built. I think they said it's got 32 degrees of freedom. And
how do we know it's not a person?
Fingers look a little too.
I'll show you what's a little further down in the website that this video comes off of. But apparently there's pressure sensing and also shear sensing in the skin. But this is like
like shear sensing, meaning it's gonna cut through the whatever skin it has.
It's like extraordinary dexterity and precision in its hands. Okay, so that's that. And then
these things are starting to get creepy.
Yeah,
that's
right.
Part of our downfall. It can plug itself in. Now we got problems.
Yeah. So this is they use tendons for operating the 32 degrees of motion, and they all live in the forearm. So this is an image of the motors spinning around, operating the tendons.
Are those do those look like, is it hydraulic? This looks like parasitic pumps or something.
So according to this, it's tendons in a tube.
Okay.
I can post the link to the page.
Now, if we can skin those grapes, now we got something. I'm just saying.
Terminator 1.
Okay, so I just posted the link to this page, but here's a picture of sort of like a zoomed out view of all those little motors operating the tendons that get the fingers and the I mean they talk about the different parts of the finger using names that are used for human parts of fingers like MCP and
metatarsals.
Yeah. And so there seems to be ropes that are like holding it all together and running. One of the big things that they the big deals they make out of this is that your traditional your jaw clamper wrist is an output only device, or actuator is an output only device. It outputs the force, and then it looks to see what happened. And what they're doing here is using force feedback to close the loop, so that they actually are sensing and experiencing the tactile sensing versus just being an output.
So you're saying are they like
all kind of sexy, right?
current-
It's just all kind of
current-
man.
What?
current measure on the motors, maybe? Back EMF on the
yeah.
motor feedback to figure out the torque?
Yeah, they didn't explain that in detail,
Okay.
but it's got a 3-DOF wrist. The joints are back drivable. It's got pressure plus location plus slip for tactile sensing on the skin. I don't know what 45 newtons is in for finger force. Do you guys know?
That's high, yeah.
What is it, like in ounces or a pound or?
You can convert like Newton meters to it could be
Yeah, but this is newtons.
inches or
How many
pound feet.
newtons in an ounce force?
I don't know. I'd have to look it up.
Okay.
Yeah.
Sounds like $6 million man.
Yeah, pretty much. So I thought that was like just a really impressive. So anyway, that's it. That's all I thought that was just really, really cool stuff.
Chris, I wanted to
Inches in a Newton meter.
go there. Chris, I wanted to thank you for your discussion of, first of all, the problem that you solved,
Mm-hmm.
as well as the attention you paid to describing the process of how you actually asked the questions of the AI tool. I am just a beginner taking baby steps in AI stuff and having some really interesting results and having some frustrating results. So my wife is in the library several days ago, and she picked up this book and brought it home. Now, is that reversed? Can you see that in plain English?
Yep.
Yeah.
So I browsed through this thing. It's a mile wide and about 6 inches deep, admittedly. Very basic stuff, but it's a fascinating approach towards the structure of how you should go about thinking about how to create a prompt and thinking about how to make it sensible and not overdone, how to describe the kinds of outputs you want it to do. It even has a section on here are the things that not to bother to include in a prompt. It's the sort of thing that causes you to begin to think about, okay, now I know the direction I have to learn more things about in terms of how to intelligently and efficiently use an AI tool. So I thought it was a very interesting approach towards how to do better with what I've been playing around with.
Yeah, but on the other hand, I mean, and how important the prompting is and the nuances to it has changed over time, right? There are certain things that were very important, very critical early on that are just no longer important. So this keeps changing. But what hasn't changed really isn't. I don't think of it as prompting as much, right? Well, there's two ways to use it, right? One is sort of more the interactive, you prompting, you're getting something back, or it's making a small change for you, or you keep going interactively, like back and forth. Okay, so that's one way of using it, and can be helpful for certain scenarios. Right now, I'm more interested in figuring out, because also at work, like how to use it to give it a bigger task, right? Give it a task that I know it's gonna take it some time to noodle on, and I'm gonna go away for an hour and do something else. Maybe get another task ready and for the pipeline, right? But for those bigger tasks, right? I mean, it's now you're not talking prompt anymore. You're talking about you're giving it a spec or a mini spec. You're giving it context. You're giving it reference documents. You're gonna have to gather up, all kinds of material, and need to tell it, by the way, there is this other material that you can look at. Here's a glossary. Here's some other thing, right? You have to tell it that these things are there. And I think the analogy really is it's you doing the same thing you would be doing if you are about to delegate a decent chunk of work to another engineer, right? Who may not be at the same level or may not have the same domain knowledge about the thing. Maybe it's a super talented programmer, right? But it's lacking the specific company and domain expertise, right? Right. So you gotta lay things out for this person, right? And that's what you can, for the tasks that are bigger tasks that are involve some problem solving and not just writing one function worth of code, but doing a whole refactor in the code base, right? You're not prompting, you're writing a spec, and you're laying out, example inputs, example outputs. Here are my expectations, right? What I want is final output in the end, and this is how you need to test. And by the way, you need to test and all that stuff. And it's you're really doing. It's almost like you're putting something together that could be consumed by a human or the AI. Right? You've got to lay these things out. Again, in the engineering world that I'm come from, you can't just throw stuff over the wall to someone else, unless that someone else is literally has the same number of years of experience as you, and the same sort of context already in this head, right? Then you don't have to lay things out. But in any other case, you got to lay things out, and that's what I did in my case here with this problem. I just laid things out the way I would if I handed this task to someone else.
Exactly. The author makes a lot of those points in his book as well, along with many examples. Trouble is, it's a mile wide. He's trying to cover all kinds of creative output of AI tools. And he also documents early in the novel that he's identified 42 different AI tools. My God, 42! Some of them we're familiar with. Most of them I'd never heard of before.
Yeah. But, I've probably mentioned this before when we talked about this. Is the one thing that is absolutely critical to get the most out of it is it has to be able to close the loop. It has to be able to test its output, right? If you're not setting it up, or your infrastructure is not in place where all it can do is produce some code and throw it over the wall back to you, and now you are the one compiling it and finding problems, that you're wasting your time, right? It has to be able to check the quality of its output. Only then can you basically step away and do something else for some time, and then come back and look at the answer. And that can be hard, right? It's easy in some cases, right? In this RAW's example, it's easy because it all just runs on the PC, right? It can run Python code, C++ code, build it, test it. It knows how to work in that environment, right? And it's evidently smart enough to, produce CSV files and analyze the data and compare one revision of the algorithm to the next revision of the algorithm. But it can do all that mechanically, right? It's all on just the same box. But when you're dealing with the stuff we're dealing with, right? You have your code sitting on an Arduino or something, right? Then how do you set it up so it can test that code, right? And close that loop, right? So you don't have to be babysit. You don't have to babysit it. So you don't have to be the one that compiles the code. Wait, you made a stupid mistake, because it will make stupid mistakes, right? It will have syntax errors in the code sometimes, right?
One of his more advanced prompt methods is one that he describes as self-consistency prompting. And he describes how to ask the AI tool to solve the problem in more than one way, and then compare the two outputs and the procedures used to determine for itself which is better. I'd never run across that before. It's quite interesting.
Yeah. Yeah, but in the software world, and that's where a lot of the things I do just the tools and in Python, and it's perfect, right? It knows how to write Python, and it's easy to test Python on the PC. But the moment you get some target hardware in the loop, it's not that easy anymore to close that loop. You gotta set it up so it can download code, it's gotta run code, and it needs to see the output of the code. But if you can put that in place, right, for whatever your platform is, then you're golden, right? Because then you can just let it make its silly mistakes. It won't be, because it will. It'll catch its own mistakes, right? And then when you go back, when you then take a look at it, you get something that's actually working. I mean, maybe it may not look the way you wanted it to look, and so on. You might have done it differently, right? But at least it'll work if you give it the mechanisms, right, to check its own quality, to check its output. But they can be hard to actually put in place, right? You have to teach it, you have to tell it, or you have to provide scripts and MCP servers and whatnot, so that it can download the code to your hardware. And so it has a way of looking at the serial port and all this stuff. There's a fair amount of setup that's needed, right, to get to that. But to me, that's the ideal state, right? So it can iterate on its own. Wait a minute, this didn't work, right? Well, it's still not working. What's going on here, right? Add some printfs, do whatever it needs to do, depending on what the nature of the platform is. And it will get to the correct answer if you give it a way to check the answer.
Like I say, I'm at baby steps so far. I don't know whether I'll ever get to the extent that you're at. Nonetheless, it's a heck of a fascinating development process.
Yeah, but just to be clear, for it working with an embedded target and closing the loop, I'm not there yet. So that's
okay.
That's to me, that's.
Well, I'll look forward to hearing more as it develops vigorously.
Yeah, hey Paul, the 45 newtons, it does convert to 33.19 foot-pounds. So
that can't be right, because foot-pounds is torque and newtons is force.
Newtons, well, a newton meter though.
Yeah, newton meters is torque, but newtons are force, and the spec was for newtons.
Oh, just newtons, not newton meters.
Yeah.
Oh, that's weird. Okay. Yeah. Yeah. If it's was 45 newton meters, that's a strong force. Like that's through a 1 foot lever
completely
arm.
Different, but it was 45 newtons.
Yeah. Yep. Which, let's see, 45 newtons. Yeah, that's weird. Anyway, if it was,
that's an appropriate way to measure force, because you're interested in two things, right? If you've got a finger, you care about how much force can it apply. You don't really care what the torques on the joints are. I mean, you do at some engineering level, but from an output point of view, you care what force it can lift. Like, can it lift a 10-pound weight with one finger? And and obviously torque is involved there, because like if it's lifting straight out versus up at 45 degrees, the torque is different, but the force is what that mass exerts.
Yeah, I look at it as okay, if it was 45 newton meters or 33, let's see, where was it?
Yeah, so it's
9 foot
45 newtons is 4.6 kilograms of if you express it as a force in
Yeah.
terms of weight, right? It's 162 ounces.
Yeah.
10
Yeah, but it
pounds.
always depends
Right.
on that force over a lever arm. So it could be over a joint. It could be, you know, over a forearm joint. So anyway, yeah, just saying it's, well, let's see, 45 newtons, that force. Yeah, it always has to be with respect to how that force is exerted. And it seems like most of these are joints that have a certain lever arm. So anyway.
Copilot says 45 newtons is 10.1 pound force.
Pound force,
Right.
Pounds of force, I guess.
Yeah.
I don't know.
yeah.
Yeah.
Okay.
And I mean, just to be clear, that's a mass of 10.1 pounds at sea level under the influence of Earth's gravity. Right?
Gravity, right. Yeah. Yep.
That's a lot for fingers, though, I think.
Yeah. Yeah.
Pretty
Right.
strong finger, you know.
I think that's what they were saying. Is that's pretty darn strong fingers.
So 4 fingers is 40 pounds.
That's a good grip right
I
there.
think it would be, yeah. If each one can do 10.
If each
That would
one-
crush your hand if you shook it.
Yeah.
So how strong is a hand grip? I'm just playing with a little scale here, but it doesn't have enough range to get a good feeling.
I don't know. I've had a couple people shake my hand that have pretty much cracked all the bones in it. Well, guys, have we exhausted our robot topics for the night?
I think so.
Well, it was a good meeting.
Good
A lot of
discussion.
good conversations.
Okay, folks. Good night.
I guess we'll call it.
Good night, everyone.
Good night.
Night,
Have
everyone.
fun on Saturday. Take lots of pictures, and we'll see what happens with Moon Day.
Will do. All right. See you guys next Tuesday.
See you guys.
Bye.